Today we are working on 2B, which is linear relationships that are not proportional. Content objective is students will be able to interpret linear relationships that are not proportional. Language objective is students will be able to explain in words the process of determining an equation using the correct vocabulary. Why are you learning this? Well, it's important for many real-life problems, one example being figuring out the amount of time to do a job. So from 7th grade, this is some background knowledge. We've talked about how to find the constant of proportionality, the equation, in both directions. We normally use output over input. That's the preferred way. And that's how we come to the conclusion that our unit rate is $4 per book. And then our equation is C equals 4B. In certain cases, you may go the opposite direction. In this case, you wouldn't. Why? Because it doesn't make much sense to say that it would be 1/4 of a book for every dollar. So which one makes more sense? Hopefully you agree that it's $4 per book would make a little bit more sense as a unit rate. We also talked about graphing and what that looks like. Here, we know that it's a proportional relationship. Why? Because it's linear and it goes through the origin. So let's go ahead and jump into our very first example. So it says here, Isaac earns $8 per hour at his job. So first things first, we're going to go ahead and start with creating a table. So here we're going to label with number of hours and the earned amount earned. So first we want to talk about how much would he earn if he hasn't started working yet. Okay, he would earn nothing. He would have no money. Now in the very first hour, how much would he have? Hopefully you say 8. Okay, and so on. How much would he have in this by the second hour? He would earn 16. Third hour, 24. Fourth hour, 32. So every hour he works, he's earning $8 more. So now let's check our ratios. We're going to go ahead and set it up as y over x. We don't use the first 0, 0 because that would be undefined. So here I would have set it up as output over input, also known as y over x. But I want you to be familiar with the vocabulary that we're going to be using. This is your input, which we often refer to as x, and this is your output, which we refer to as y in most cases. There are going to be cases where we use different variables, but just in general, that's the format that we follow. So here, first one, I'm going to have 8 over 1, which equals 8. Second one would be 16 over 2, which also reduces to 8. Next one would be 24 over 3, which reduces to 8. And last but not least, 32 over 4, which also reduces to 8. So now we can go the other direction, and here in this case we would do x over y. You're going to notice that we would still have a constant rate of change. So since the ratios are equivalent, it is a proportional relationship. So my unit rate would be $8 per hour. It makes a lot more sense to say $8 per hour versus $1 per 8 hours. Okay. So here I'm going to go ahead and label the input H and the output A. And the reason why I chose this would be because H for hours and A for amount. So here's a prime example where you won't always use X and Y, but in general, that's your default. So my equation would be A equals 8H because you're following that form Y equals KX since it is a proportional relationship. So here, let's talk about the different pieces of our equation. H is your numerical value of your unit rate. Okay, so here's what our graph would look like, and it's exactly what we would expect. We would expect it to go through the origin and that it's linear. So these are the points that were graphed here. So the graph shows us that for every $8 earned, he worked 1 hour. So let me show you. So here, as it's going up $8, it's because he worked for 1 hour. Okay, and again, if you continue to follow this, he's earning $8 for every 1 hour that he works. Continuing on, 8 hours. Oops, not 8 hours. $8 for every 1 hour that he works. So this is a visual of our unit rate, okay, that he's earning $8 for every hour that he is working at his job. So now what happens if our graph went from looking like this to something like that? Is that a proportional relationship? Hopefully you say no. And why? Because we can say that it's not going through the origin. Yes, it's linear, but in order for it to be a proportional relationship, it also has to go through the origin. So this isn't a proportional relationship. So what might that look like in words? How about maybe like number 2? Number 2 says Isaac currently has $5. He then earns $8 per hour at his job. So starting with the table, let's go ahead and label our X and Y in our table, number of hours and the amount earned. So 0, okay, if he didn't work at all, how much would he have? He would still have $5. Here's what we would call the initial value, because this is how much he started with. Now, after every single hour, okay, so let's see, next hour, how much would he have altogether? He would have 13 because he's earning $8 on top of that 5 that he already has. So the second hour, he'd have 21 because you're, again, adding $8 more to what he already has. By the third hour, he'd have 29, and by the fourth hour, he'd have $37. So real quick, let's check out the ratios. Again, we are going to put output over input, which we've been referring to y over x as well. So here, you don't want to use 0 over 5 because that's going to be undefined. So I'm going to go ahead and put 13 over 1, which is 13. Then we're going to do 21 over 2, which is already reduced. So at this point, I could stop already. Why, you might ask? Because based off of the ratios that we computed, there isn't a constant rate of change. So this is not a proportional relationship. In fact, looking at our initial value, it's not a proportional relationship because it's not going through the origin, because it would have to be 0, 0. So just to prove my point, I'm going to go ahead and show the other ratios and show that they are definitely not equivalent. Even if I went the other direction and did input over output, the ratios would not be equivalent. So this is not a proportional relationship, okay? Again, you can look at the ratios. You can check that it doesn't go through the origin, so things like that. So even though it's not a proportional relationship, there still might be an equation we can use to represent this scenario. So right now, go ahead and pause the video and try to find an equation that would work for this case where Isaac is currently has $5 and he's earning $8 per hour at his job. Okay, so let's check it out. So here, our equation, hopefully you guessed right, is going to be, if I let H represent the number of hours and A be the amount earned, it would be A equals 8H plus 5. Okay, and this is what our graph would look like based off our table. So here, notice it doesn't go through the origin. It's linear, but in order for it to be a proportional relationship, you would need the graph to have both attributes. It would have to go through the origin, and it would have to be linear. And since it doesn't go through the origin, it's not a proportional relationship. But this graph can still show us that there is a unit rate. So here, the graph is showing us that for every $8 that he's earning, he's working for 1 hour. Again, for every $8 that he earns, it's because he worked for 1 hour. So this graph is illustrating to us our unit rate. So there's going to be different ways of finding the unit rate. So the unit rate is $8 per hour, and since it's not a proportional relationship, there isn't a constant of proportionality. Just because there isn't a constant proportionality doesn't mean there's no unit rate. So I want to make that clear. There is a unit rate, and our graph shows that to us right here, that for every $8, he is working for 1 hour. So here, the numerical value of the unit rate can be found here in our equation next to our variable. And our constant in this case would represent our initial value. So even though he didn't work at all, Isaac started with $5. So that's the initial value. So go ahead and write this down. Our initial value is usually the value at the beginning of the situation, or when the input is equal to 0. Okay, so in other words, if x equals 0, our y would be our initial value within that ordered pair. So let's take a look at number 3. It says Courtney is collecting coins. She has 2 coins in her collection to start with and plans to add 4 coins each week. So what's her initial value? In 0 weeks, how many coins does she have? Well, according to this, she has 2 coins. So I'm going to go ahead and say that the initial value would be 2. At 0 weeks, she has 2 coins. By the first week, she would have 4 more coins. So that would make 6. By the second week, she would have 4 more coins. So it gives you 10. By the third week, she'd have 14. By the fourth week, she would have 18. By the fifth week, she would have 22. And by the sixth week, she would have 26. So you're adding 4 coins every single week when she initially starts with 2. So now that you have a graph, we're going to go ahead and graph it. There's going to be cases where you're going to have to scale your graph in order to fit these different values that you would get from your table. Here, I'm going to just demonstrate for you. I'm going to go ahead and go by ones in the x-axis and label that time in weeks. And then for my y-axis, since the numbers are a little bit larger, I'm going to go ahead and go by 2s. And this is going to represent the number of coins. So all I would have to do is graph it and draw a line that extends through the graph. Okay, here my equation would be, if I let t represent weeks, if you're wondering, just because t is representing the time, and I'm going to let c represent coins, it would be c equals 4t plus 2. Okay, our unit rate would be here, if you take a look, every single time she is getting 4 more coins for each 1 week that passes by. Okay, again, 4 coins for the 1 week that passes by, 4 coins for the 1 week that passes by, and it continues on and on. So this graph shows our unit rate. So that's one way of figuring out our unit rate, is you can even look at the graph. So I would say there's 4 coins per week. Here I would say my initial value is, looking at our graph, at 0 weeks, she had how many coins? She would have 2 coins. Or you can see it right here in our table. At 0 weeks, she has 2 coins. So notice our initial value is not just a number. It's actually a statement. So make sure you just don't write one number by itself. So here, there's different ways of saying it. You can say at 0 weeks, Courtney has 2 coins. You can say Courtney started with 2 coins. So again, there's different ways of stating it. Just don't put 2 by itself. So now moving on to number 4, it says an airplane is at an elevation of 300 feet. The table below shows its elevation y for every 2 miles x it travels. At this point, I want you to go ahead and pause the video and try it on your own. Okay, so now let's check out our work. So first things first, what I'm going to do is I'm going to have to scale my graph so that I can fit the numbers that I have based on my table. So the x-axis, I'm going to just go ahead and have it go by ones. And then I'm going to go ahead and label it miles. Now, for the y-axis, since the numbers are so large, I'm actually going to go by the 500 increments. And then make sure I label it by the elevation. So now I just graph 0, 3000, 2, 2000, and then 4, 1000 would be right here. Draw my line, make sure it extends through the graph. So my equation would be, if I let x represent miles and y represent elevation, some of you might have chosen different variables. As long as you label it in your table, that's totally fine. But using x and y, I would have y equals 3000 minus 500x. Our unit rate, okay, let's take a look by observing our graph. Here, you are declining, okay, 500 feet for every 1 mile. Okay, let me use a different color so we can see that a little bit better. Okay, again, it's 500 feet for every 1 mile. Again, would be dropping 500 feet for each 1 mile. Again, 500 feet for each 1 mile. So here I would say my unit rate is it's dropping 500 feet per mile. Our initial value, if you take a look at our graph, starting at 0 miles, so our initial value at 0, if our input is 0, it would be 3000. Or you can look at the table. By 0 miles, the elevation was at 300 feet. So again, just don't put, 3,000. So once again, please just make sure you don't write 3,000 by itself. You want to explain what the initial value is. So you can say, at 0 miles, the plane was at an elevation of 3,000 feet, or you can say the plane started at 3,000 feet. There's different ways of saying the same answer. Okay, so moving on. Now what I'm going to have you do is, using just an equation, we're going to graph. We're going to graph it. So here I did have values inputted for you, 0, 1, 2, 3, 4. So I'm going to show you how you would do the first one. Here, if x is 0, what is y? All you're really doing is, I'm just going to go ahead and rewrite this. Y equals 3 times the value of x plus 3. So for the very first one, if x is 0, okay, what is y? Y would be 3 times 0 plus 3, which is 0 plus 3, which gives me 3. Okay, and so on. Do that. Now what if x is 1? So you're just going to replace this with 1. If x is 1, you would have 3 times 1, which is 3. You add on this 3, and you would get y equals 6. One more time, what if x is 2? We're just going to replace our x value with a 2. Here, y equals 3 times 2, which is 6, plus 3, which would give you 9. So go ahead and finish this table. Okay, so hopefully you ended up with, when you input 3 for x, you get y equal 12, and when you input x 4 for x, you would get an output of 15. So on your graph, you want to make sure you scale it so that the outputs and inputs that you got from your table fit within your graph. Here, I'm just going to go by 1s for the x's and 1 for the y's because they're going to fit. And then graph my points. So the unit rate can be found here in our equation right here. This is our unit rate, okay? Which means for every 3, let's change this color so we can see a little bit better. For every 3 y's, because it's moving by y's, it goes 1x, okay? So it's a different color because it's not very dark. Again, for every 3 y's, it's going by 1x. So you're going 3 y's for each 1x. Okay, so in other words, you can say 3y for each x. Now our initial value, we got to talk about where did this graph start at. But at 0, when your input was 0, what was your output? Well, my output was at 3. So you can see it within the graph here, or you can look at the table. So again, when your input is 0, what is your output? Okay, so here I would say at x equals 0, y equals 3. Or you can say when x is 0, y equals 3. So again, there's different ways of saying the same thing. Okay, so now here, number 6, go ahead and pause the video and try this one on your own. Okay, so here what you're going to do is you're going to put y equals 14 minus 2 times some value for x. So here, what if x equals 0? What is y? Well, 14 minus 0 would be 14, so that's my initial value. Why? Again, because when x is 0, your output for y is going to be your initial value. It's what it started with. Okay, now what if your input is a 1? What is your output? Hopefully you get 14 minus 2, which is 12. And one more time, what if your input was 2? Here it would be y minus 14 minus 4, which is 10. So hopefully you got the idea, and you got 3, 8 and 4, 6. Sorry, I'm saying them as commas because I would translate these into ordered pairs for when I graph it. So here you don't have to scale it much because it is going to fit within the graph you're given. I'm just going to go by ones. Now here, graphing it, you're going to see that our unit rate is negative because it's declining. Here, let me prove my point. It is dropping, okay? Y is dropping 2 times for each x, for each 1x. Again, 2 is dropping, it's dropping 2 y's for each 1x, etc. So I would say my unit rate is negative 2y for each x. If you're talking about initial values, well, where did this graph start? Well, when x was 0, it started at 14. So you can say at x equals 0, y equals 14, or you can say when x is 0, y equals 14. So you can see it in the graph. You can, in fact, in this case, even see it in your table. When x is 0, y is 14. But looking at our equation here, this is our unit rate value. Okay, and you can see that it's negative and that it's declining. And this number here is our initial value. So there's multiple ways of finding these features. You can definitely look at your equation, you can look at a graph, you can look at a table. So be observant of all these types of forms of the same thing. Now, for number 7, it says write an equation for the following graph. So first things first, you're going to want to find some perfect intersections to determine easy ordered pairs. So going down this, going down this line, our graph, I'm going to find a point here. Sorry, first one's actually here. So I'm going to go ahead and put 0, 6. Here I see 1, 12. Over here I see a 3, 18. Sorry, 2, 18. Here 3, 24, and here 4, 30. So at this point, I'm going to determine the unit rate by looking at our graph. It looks here that it's going up 6 papers for every here it says 1 hour. So you got to be careful and you take a look at your scaling. Just don't always assume this is 2 because you see 2 boxes. So here it's 6 papers. I'm just going to put P for short for every 1 hour. 6 papers for every 1 hour. So here I'm going to say the unit rate is 6 papers per hour. Our initial value, if we take a look at where it started with, you can say by 0 hours there was 6 papers already graded. So I'm going to say at 0 hours the number of papers graded was 6. So again, you can say what I just said. You can say by 0 hours there was already 6 papers graded. So again, there's slight variations. As long as it means the same thing, it's going to be right. So now that we have our unit rate and our initial value, we can create our equation. In this case, it's going to be y equals 6x plus 6, where this is our unit rate here. And then here is our initial value. So in order to create an equation, we're going to need these two things. We're going to need a unit rate and we're going to need our initial value. So now moving on to our next example, what I'm going to have you do is go ahead and pause the video and try this one on your own and see how well you do. Okay, so we're back. We're going to go ahead and check our work. So hopefully the first thing that you did was went ahead and found some nice ordered pairs. So 0, 10,000, 2, 9,000, 4, 8,000, 6, 7,000, 8, 6,000. The next thing you did was search for that unit rate. So here we're going to look at our graph. So first things first, you want to know how much it is within 1 hour. So we're looking at this coordinate right here. I know right now it's not very clear as these nice intersections, but here in 1 hour, I'm going to go ahead and say that it dropped about 500. And why am I able to say that? Because if this started at 500, if it dropped another 500, it would leave me at 9,000. So I'm going to go ahead and say that the unit rate is it's decreasing 500 gallons per hour. If you're wondering how I got those units, I'm basing it off of the units given here. It is dropping 500 gallons for every 1 hour. Oh, let's fix that. For 1 hour. And again, I get that from here. So again, it's dropping 500 gallons for every 1 hour. So our initial value, where did this graph start? Okay, here, initially it started when time is 0, when no time has passed, the container or whatever we're talking about had 10,000 gallons. So again, you can look at the graph or you can look at the table here. When our input is 0, our output is our initial value. So here, we can say at 0 hours, the number of gallons was 10,000. Okay, or by 0 hours, there was 10,000 gallons. So again, slight variations, but it means the same thing. So here, now that we have both our unit rate and our initial value, we can create an equation. I would say V equals Y, because there's variables given to us here. So V equals 10,000 minus 500t. Here, 10,000 represents our initial value, because that's how much we started with. But then based off of that, we were losing 500 gallons per hour. So this would be all our unit rate. And there you have it. That concludes our lesson for today. Thank you so much for tuning in. And until next time, bye.